Okay, so this is problem 11.5.43. They ask us to use the binomial theorem to find the coefficient of x to the 7th in the expansion of x minus 3 to the 10th. Okay, and so what we want to do here, the binomial theorem, you know, I mean, it looks like this. You know, looks like n things taken 0 at a time, and then you have x to the nth, and then it's plus n1, and you have a times x to the n minus 1, and so on. And you know, just this pattern just continues. Okay, so if we're looking at x minus 3 to the 10th power here, we're looking at an a equaling -3 and an n equaling 10. And what I'm going to do is just write this out to the point where we get, you know, the x to the 7th, which is the one that we're looking for. And then we'll just work with that term. Okay, so if I were to write this out, this would be 10 things taken 0 at a time. We'd have x to the 10th, and then we'd have 10 things taken 1 at a time. We have -3 to the 1st, and x to the 9th. And then 10 things taken 2 at a time. We have -3 to the 2nd and x to the 8th. And then here's the one that we want, 10 things taken 3 at a time. We have -3 to the 3rd and x to the 7th. And notice that, you know, in all of these, the powers end up being 10 if you add them together. And that's one of the properties of the binomial theorem. Okay, so this is the one that we're concerned with, and they wanted us to find the coefficient. Okay, and you know, by the way, this continues. I'm just stopping there because this is what we need, this term. So this right here is a combination, and you could use Pascal's triangle to get this number, but you actually have to expand Pascal's triangle pretty far out to, you know, the number 10. And so yeah, I think I'll just use a combination there instead. So the combination 10 things taken 3 at a time is 10 factorial over 3 factorial times 10 minus 3 factorial. And that's times -3 to the 3rd. That's this right there. And then we have x to the 7th. Okay, so this piece right here becomes 10 factorial over 3 factorial, and we have 7 factorial. -3 to the 3rd, that's actually -27. So this is times that. Okay, and then we have x to the 7th. So if I were to write out 10 factorial, and I'm just going to take it down to the place where I've got a 7 factorial so that I can cancel with the 7 factorial that's in the bottom. Okay, so 7 factorials cancel, and I have 10 times 9 times 8. So that's 720 over 6, and this is times -27, x to the 7th. Okay, and then there's some reducing that can be done there. Actually, we could have reduced right here. I think I'll do that. So 2 goes into 2 once, into 8 4 times. 3 goes into 3 once, into 9 3 times. So we have 10 times 3 times 4. That's actually 120. So this is... So this ends up being 120. And then we have times our -27. So that was just the factorial piece, times that -27, x to the 7th. And if you take 120 times -27, I believe you get a -3240, x to the 7th. And I'm going to check that number real quick, make sure it's right. Yep, 3240. And then they just asked for the coefficient, so they're actually just looking for that number, -3240.